Hello, guys, and welcome to another episode of our programming course. I hope you enjoyed so far and you have done your homework and everything went well for you, and other good stuff that I wish for you. At the previous session, we have done this code that you can already see, and I just noticed that I can zoom in the code so you can see this better. Uh, we have a method called getStudent, which creates a student but in fact returns a dictionary. A dictionary is just a set of key value pairs which you can access any key. Uh, and each key has its own value actually. In this case, a student is a dictionary which has three keys called name, age, and grade, which it gets from the user prompt. And at the last, we have a list of students, which is in fact a list of dictionaries. You might notice that so far we have just used the default type values such as float, integer, string, dictionary, list, etc. And they call it primitive types because they are just exist by their own. They are not built up of any other thing, and they are available just out of the box. So we call them primitive data types. But there are other data types which we can make some of them by stacking some primitive data types. For example, in this student thingy, we could have just combined three data types as string, integer, and float, and create a new data type called student. Wouldn't that be a bit, you know? Wouldn't that be a bit more beautiful? You could have just have your own data type, which you can store anything you want. That seems fascinating. And that is not a dream. That actually exists. We call it object-oriented programming, or in a shorthand, OOP. Most of the programming languages support this feature, but we are not going to talk about all the difficulties and complexity of OOP. We just want to start with some basic usages to just find out what is it, how does it work, and how to use it. So let's dive it without any further explanation. I will just keep my code below, and I'll try to write my new code based on the existing code. So first of all, we are going to define student class. Oh, I said class. I mean student data type. They don't differ. They are technically the same, kinda. So a student class, a student data type, doesn't matter what you call it. It's student. We are going to define student, but you might kinda notice that we're starting with the exact syntax of a function. So how the Python is going to know that this is a data type or a class, not a function? So we have to mention class student, and as like anything in Python, we have to use colons and the definition inside the colons or block. We could just pass, or we could just call the properties. Let's call the properties. Student has a name which is string. Student has an age which is in type of integer, and the student has a field called grade, which is a float. So we have kind of defined our student just based off the primitive data types. Isn't it great? It gets more funny, you know. Stay tuned. Uh, let's go with that. I will add some complexity later. I will add an exit here so the rest of the code will not be executed. Let's make the variable s1 equal to student, and we have to kind of call this like a function. We have to write the parentheses. I'm going to say y in a few minutes. You might notice that we have used the exact syntax for list, dictionary, float, integer, whatever, because they were all classes, they were data types, so we have made a new data type, so we have to treat them like it's actually a new data type. So all right, we have student, so let's print it and see what is inside that. So if we print that, we can kind of see that this is a student object at somewhere at the memory. It's a hex address at the RAM or memory. So I can call the property of name of a student. I can access it and it's nothing. You can say I can assign a variable, so I can say the name is like whatever, John, and other properties like, come on, like the age is 21 and the grade is actually 19. So if I print this, I will clear. Yeah, my bad. So if I run this, I can see the name, and if I print other properties, we call those little primitive types properties, because they are for a student, they are their property. So if we get those, you can see that we can easily access those values. So this is the way that you can create a data type based on another data types. They could be primitive data types, or the data types that you have defined yourself or somebody else has defined it, and you just can use it as a library. I kind of told you the name of this phenomenon called library, but never mind, we're gonna learn it later in this course. So we have defined a student as it has 3 properties, and each property or another primitive data type, they could be the same. I can add a property called height and it could be integer again. It doesn't have to be unique, or it could be unique, whatever that your situation requires. There are no limitation whatsoever that which way you should implement this. So this printing is a bit messy. We can define a function, we call it print actually, and inside that I'm going to print those. Isn't it a bit great? You can easily, you kind of can see that I have defined this method inside the class, not out of the class like this. So you are getting familiar with another phenomenon. We call it method. A method is a function inside a class, so it determines the behavior of that object. Oh, what is object? That getting interesting, we have a variable, we call it s1, and it is a student type. We have just built it, so we don't call s1 a variable. That's an object. Names. So that's the object, and the methods or the function inside that class can determine the behavior of that object, but they have a rule. All the methods should at least have one argument, and that argument must be self, which kind of points to the current object. So instead of s1, I'm going to write self. It doesn't have to be the exact name of self. It could be just like me, and you can just refer them by me, Python accepts that. It doesn't have to be the exact word, but it's a convenient, and it's an unwritten agreement. Nobody wrote that rule, nobody has talked about it, but they are always using it, that the first argument must be self. That actually helps for the Python developers to understand a variable. For example, your method could be a bit larger, or be like 10,000 lines. That's not actually a thing, but it could be messy, it could be full of variables and stuff, and you could just by looking at the name of the variable, find which variable is self, which actually refers to the object itself. So instead of those printers that were exist there, I can call the print behavior of this one. So this is equal to saying print and passing s1 to it, but for objects we have to treat them as a properties. You kinda can see that this print has one argument and I passed none, because the first argument is always the object itself. That's why the Python methods must have at least one argument. So I call the print. Let's run the code. We see the exact result just like before, and that shows that our method works actually perfect. So we can, this assigning variables are a bit messy too. So wouldn't it be more efficient to just pass these values here, 21 and 19 here? Wouldn't that be great? So if I run this again, it says that a student takes no argument. Why it is? When you create an object and a magic method has been invoked, it automatically getting called without you ever knowing, and that's the constructor. That actually constructs the basic levels of your object. That's the first method and the first behavior of any object. We call it constructor, and a constructor in Python is underline init. Yeah, but you have to add the define init, and you can see kind of that it completed my code here, and it assigned the first argument as self, and it just I left the body empty. So after the self, because the self is obligatory, you cannot change it. You shouldn't change it because that's your object, basically. So let's get the variables like name, age, and grade. You kind of can see that the variables are the same name as the properties. Oh, that's getting quite a lot. Those are variables, those are properties, they are a bit different from each other. At least they are at different scopes, so they are not interfere with each other. So you can just say self that name is equal self dot name is the name. So it knows that this name is the argument, it highlights it, and the other name is the property. The Python can understand which is which it is. So don't worry about that. The arguments and the properties could be the same name, and the Python can actually detect the difference and treat them differently. So the self-grade is great. So we don't actually need that anymore, and I can run the code and I can see the values here without getting an error that says student takes no argument. Actually, I've passed 3 values here, but I have 4 arguments, and there is nothing behind that kind of thingy, which we can call it the first argument. So yeah, as I can said before, the first argument is obligatory. You have to have it. You cannot ignore it. That's the rule. That's the law. So that's how it works. And just like all the other functions, you can override the values. For example, if no grade has passed, you can assign it as none. Age could be 0, and the name could be an empty string. So if I never pass these values, it just says nothing or empty string, 0 and none. But if I didn't pass those the default variables, if I didn't pass those defaults here, like so, when I pass nothing to it, it raises an error and says that the student init has 3 required arguments called name, age, and grade, and they were obligatory. But if we kind of add those defaults, like the name is an empty string, age is 0, and the grade is none, or you could just enter whatever value you want, and if you pass nothing to it, it will construct a default state of that object. That's the reason we call it constructor, because it constructs it. So I'm going with the values John, age of 21, and the grade of 19. So if I print that, it actually works. So the last method it misses is the actually get the student. So we need something to read the proper values from the user prompt. I'm going to copy paste that and call it read. So you know that we have to pass an argument. I call it just self, and instead of a student name, I'm going with self.name, and instead of a student age, I'm going with self age and removing those extra parts, and self.grade. Yeah, that it I believe that is enough. So right now I have three methods inside my student thingy. So I have created a student, I print it, so you know that it's going to be the default values. I can call the read function, and then I print it again to see the difference. So let's clear that, clear here, and if I run it, it says nothing, 0 and none, because that's a default thingy, and it kind of reads it. So enter the name, okay, John, the age 21, and the grade is 18. So it just prints that again and exits. So everything works fine, and you have kind of got familiar with the Python classes and the basics of how to write a class. What is a class? What is method? What is object? What does constructor do? And what? And how to create a custom data type, which is not a primitive data type. You know, you can uh, stack up as many as primitive types you want to create another complex data type, just like the student. A student was not existed in the Python out of the box. We just created and taught the Python how a student works and what's the behavior and what does, and etc. And suddenly it works just out of the box. You know, if you ignore this class, if you just consider this class were defined somewhere else, which we are going to discuss it later as libraries, the Python code for this whole operation is just these 2 or 3 lines, maybe 4 lines. That's it. And that's the reason we use OOP, because it shortens our code by really a lot. You know, you can use this as a student over and over again with all the other properties. They are stored separately and safely. They can interact with each other and also interact with other function or classes. You know, you can build a lot of complex things just by this simple class. So after this the elementary course that you can currently watch, I kinda may, I'm not promising anything, I may just record an advanced programming course, which I explain those by details at that course. But for now, that's what it is for the day, and I hope you enjoyed it. There are a lot of new things that I have discussed it, and I just told you that what is what, and you might not have enough chance to learn it at the first sight. You have to pay attention to it. You have to practice. Sometimes you have to define other data types, such as a teacher or the school, and something like that. And please do that, because for the next episode we are going to do the same, and adding some interesting behaviors, so the school can have teachers, can have students. Students are belong to school, and every teacher and a student might have a relationship, not that kind of relationship. They could interact with each other. For example, the teacher could assign the grade for the student and stuff like that. But for now, you just create those classes based on what I've told you so far. So if you had any other questions, the comment section are open. You can ask whatever you want, and I might read it in the future. Have fun, and that is for today. Take care.